So here's problem 3 from the week 2 homework for building construction for the fire service. You can see in this problem that we're going to be doing vector addition, and the first step to doing successful vector addition is we need to break these vectors into their vertical and horizontal components. So let's just draw those components in. If you think about the set of vectors that would result in the given vector in red, it's going to be a horizontal and a vertical vector with their orientation head to tail. So just like this. So a leftward and an upward vector produces an upward and a leftward diagonal resultant vector. We know that the angle here is 60 degrees. We know that the hypotenuse of this triangle is 110 pounds. And we know that this side is adjacent to the angle and this side is opposite to the angle. So we're looking for the lengths of sides O and A, and so we'll need to use trig functions. And remember our kind of memory aid here, so, ka, toa. In this case, we're interested in relating the opposite in the hypotenuse and the adjacent in the hypotenuse. So what do we know? Well, we know the sine of 60 degrees equals what? Opposite, which we don't know, over hypotenuse, which we know is 110. Well, how do you get opposite by itself? You multiply both sides by 110. And so we could rewrite this as 110 pounds times the sine of 60 degrees equals the opposite side. So we'll use our trusty scientific calculator here, clear out of everything. 60 degrees. And we will take the sine of that, and then we will multiply by 110. So what we find is that this horizontal vector here, this horizontal component, has a magnitude of 95.3 pounds approximately. So let's just write that in. Now, part of solving this is we need to create a free body diagram where we can kind of stack up all of these little components that we've figured out. So I'm going to draw a dot, and coming out of the dot going upward is a vector, straight upward, 95.3 pounds. Now the horizontal component, well, then we have to relate adjacent and hypotenuse, so we use the cosine. So again, cosine of 60 degrees equals adjacent over the hypotenuse, which in this case is 110 pounds. 110 times the cosine of 60 equals the adjacent side length, which equals, let's punch it up, $60. Cosine is 1/2 times, oops, 110. 55 pounds. And if we look at the direction of this angle, it is to the left, so we're going to have a leftward pull of 55 pounds. The next step is to break the other vector into its components. So this vector will have a horizontal component to the right and a vertical component downward. And this is an interesting case because this is a 45-45-90 triangle. It's an isosceles triangle, which means that we could consider this side A and this side B, and they would be equal by properties of isosceles triangles. So you could do something like 2a squared equals 60 squared. But in this case, we're going to stick to our trigonometric methods. So what do we know? The angle here is 45 degrees. This would be the adjacent side. This would be the opposite side. So let's relate. Let's figure out that adjacent side first. So again, we're going to use cosine to figure out the adjacent side. So cosine 45 degrees equals A over, and the force in this case is 60 pounds. Multiply both sides by 60. 60 times the cosine of 45 degrees equals 45 cosine times 60 about 42.4 pounds. So if you look at this vector, this 42.4 pounds vector here, it's to the right. And we're going to apply that to our free body diagram right here, and you'll notice that this vector to the right is going to be canceling out part of the magnitude of the vector to the left, which we'll resolve in just a moment. Let's work out the height. Now, if you think about this, if this is an isosceles triangle, a 45, 45, 90 triangle, what should be true about the length of the opposite side? It should be equal to the length of the adjacent side. So that can be a good check on our work. So again, sine 60 degrees equals what? Opposite over hypotenuse. Opposite over 60. 60 pounds times the, whoops, this is 45 degrees, not 60. 60 pounds times the sine of 45 degrees equals
I will see, and I'll see if I have the far.
So if you'll notice, the sine of 45 degrees and the cosine of 45 degrees are equal, and that kind of makes sense because, like I said before, when you do enough of these problems, you're going to start to think about the cosine of an angle as being the horizontal component and the sine of an angle being the vertical component. And we know in a 45, 45, 90 isosceles triangle that the horizontal and vertical components are equal. So this is a good indication that we're on the right track. Now we need to multiply that by the force, which is 60. And we find that the vertical component is, again, 42.4 pounds. So we could have a 42.4 pound downward force from this other vector. Now, the final step is just simple addition of these vectors that are opposite of each other. So we have 95 pounds upward, we have 42 pounds downward. Let's find out what the net result of that is. So 95.3 minus 42.4, and that's because the 42.4 is in a downward direction. And we find that the result in the vertical axis is 52.9 pounds vertically. So let's draw a free body diagram for that. 52.9 pounds. And let's look at the horizontal component. So we have 42.4 pounds to the right, and we're going to subtract from it the 55 pounds because it's in the leftward direction. And we get negative 12.6 pounds. Now, the negative just denotes that this is going to be left on the x-axis. So we will draw this here. And this is 12.6 pounds. Now, the final thing that we need to do is we need to get this down into a single vector. So up above, we've decomposed a single vector into its components. Now we are going to compose from the components a single vector. So remember the steps that are involved with that. The first step is to slide the vectors head to tail. So I'm going to take my 52.9 pound vector and draw it again. And I'm going to take my 12.6 pound vector and I'm going to slide it so that its head is on the tail of the 52.9 pound vector. Notice I did not change its direction, right? You can't just, for instance, move the arrow. That won't work. You have to actually slide the vector. Now, the question is, what is this resultant? Well, this is a simple case of Pythagorean theorem because by definition that angle is 90 degrees because we said that one vector represented a force in a vertical direction and the other represented a force in a horizontal direction. So let's call this vector, I don't know, r for resultant. So what does r equal? Well, first let's use Pythagorean theorem. 12.6 squared plus 52.9 squared equals r squared. Well, how do you undo the square? You just take the square root of both sides. Now remember, you cannot take the square root of parts of sums. So what we have to do is we have to turn the crank on all of this stuff inside the root symbol first. So let's work on that. So 12.6 or negative 12.6, it doesn't really matter because the square is going to wash out the minus sign. If I square that, I get, let's write these down, square root of 158.8 plus 52.9 squared $2,798.4. And again, that's equal to, essentially we could think of it as the square root of r squared. Well, on the right side, really, we can just cancel, right? Because there is no sum, so I can just strike the square root sign and strike the component. That is equal to r. Now it's just a matter of summing those two values together and taking the root. So I'm going to add to that 158.8. And then I'm going to take the square root, which on this calculator is easily done by raising to the 1/2 power. So the final resultant is 54.4 pounds. Equals the magnitude of r. Now you have to think, is that reasonable? I mean, after all, we've got vectors with forces of 110 pounds in the original and 60 pounds. But what you have to remember is that components are canceling each other out, so that as we look at this free body diagram, it becomes clear that yes, this is an appropriate magnitude. Now the final question is, okay, at what angle? Well, because this 12.6 pound vector represents the x-axis, basically we are looking for the supplement to the angle given here. We're looking for this piece of it, right? So first let's find this included angle, and then we'll subtract the included angle from 180, which will give us the direction of vector r. So what do we know? Well, we know the opposite and adjacent sides. So tangent of angle theta equals 52.9 over 12.6. And the problem is that the tangent function is designed that you throw a number of degrees in there and it spits out a ratio. So what we're going to have to do is we're going to have to use the inverse function, the arctangent, or tangent to the -1. So arctangent of 52.9 over 12.6 equals angle theta. So the first step in calculating this is going to be to do what's inside the parentheses. So let's figure that out. 52.9 divided by 12.6. Okay, so the ratio of opposite to adjacent is a little over 4. Now we're going to use the inverse key, arctangent, and we find that angle theta is approximately equal to 76.6 degrees. Now, the last step of this is to think about what is the supplement. So what adds to 176.6 to give you 180? Well, 180 minus 76.6 would be 104, but then we got to take care of that 0.6, so 103.4 degrees. 103.4 degrees is the angle, and again the magnitude we figured out was 54.4 pounds at 103. So we can draw it here, 54.4 pounds